It's time for us to start. Hello and welcome. My name is Bogdan Vlodarsky. I'm a data quality lead at Provectus. We're a consulting company, usually in the AIML, migration, data migration, and others. Then I'm going to tell you about the data quality. I'm going to tell you why it's needed. One of the main principles. Probably those of you who work with data, EML, will find it also interesting. As a tester, you may find it also see the new way of going forward. First and foremost, what is a data QA? It could be obvious from the data is something that has to do with data and QA. It's validation of the data. It's includes also collection of the statistical data, like profiling and search for some anomalies in the data and cleansing. Usually it's a separate step, not included in the data quality assurance. Why it's important? Because from point of view of business, we can see that many companies that work with data receive more and more data, buying it from third parties, but very often they don't make sure that data is fine. But we need to agree that everything is bad with data, but we don't know how bad it is and where the problems are. Every year, the cost of the mistakes that is growing from the point of view of businesses. But from a technical viewpoint, from the point of view of machine learning, you can say the potential of data clearing, data QA is many times more than it changes in the algorithm. First and foremost, you need to assure quality assure your data to continue. The chart says that the data QA is 20 times more in terms of potential. When companies should use data QA? Always when you have the data, be it a big or small company, but if, for example, your company is built around the data, for example, you built in a making financial reports for your management, working with BA, you could also be buying data from other companies, thus enriching your data sets. Or when you're creating data lakes or making some data pipelines. So, yes, if you have data, better use it. What are the dimensions here? In terms of data testing, the first and foremost is accuracy. Simple example, in some of your website form, you put the age of your client being as 34, but in fact, your client is 32. There's some inaccuracy, we don't know where, but it's one of the testing stages. The next layer is completeness. Going back to the web form, we'll pretend that you get full name patronymic, including the last name, but you only get half part of it. And then you have some data aggregators that use the last names without it being there, so that your data will fail. Next layer is consistency. Bookkeeping department. One of the tables said that this person gets that much money on this date. Another table says that this person has been sacked. So this way we'll get extra cost on operations. Next layer is the timeliness. Again, we can look back at financial reporting. Maybe last time there was some processing in the last month. If it's the one before last, then the data will be invalid and non-applicable. And lastly, basically one but last, is the validity. Its correspondence to satisfaction of business rules. Let's say we have a data format that we need to present in the European variant, and if we get it in the American variant, they will not be used properly. Next one is uniqueness. It happens when we enrich the data, so we use the same metrics, the same people. No, our algorithms will not be working properly because the data overlaps. It needs to be detected and cleaned. I'm going to show you what the tests look like, so you wouldn't think it's so complicated. Very often it's just the regular Python code or some variations of the JSON formats or SQL similar syntaxes. We see the validity being checked. There's a check that the employee number is a digit. This is all that is relevant to the validity category. After test suite is used, we'll see the final result that is a digit will not divide this digit into the category, is collected together. So you can use any dimension to start the test. Next, a few words about the real examples that we had in our company. The first one had to do with the comparison of data. This is a very in case it happens often. They know that clients know there's something wrong with their data, but they don't know where the problem is. For example, an algorithm or the model is written using one engine, one language, and then it's transferred to another one. But the pipeline needs to be in action and workable, so we can upload two data sets and compare where mistakes are. And the user will see that and will be able to fix it. So this way we are showing this. In which columns there are discrepancy, in which lines there is a discrepancy, and so on. Next example is the DB migration, or data migration. This is a popular case. Company usually work with such issues when we have a database in one cloud or in one account or in a local server, and we want to migrate the data and move it to the cloud. Here we often use the approach called CDC, when all the data is collected in a chunk and then it's sent to the data lake, or there's a migration to a concrete database. What do? We take this chunk of data, we test it. First, we need to write those tests. How is it done? There are two approaches. The first one that we usually use, it's a basic one. It's called role-based algorithms to generate tests. So this is done on the fly. We receive a data set, and there we generate tests automatically. We run them, they're saved where needed, and then they're shown to the client. And then it can be set up. The second approach is manual writing. It's more time-consuming, but you must find a person who's responsible for a certain data source, table, or database. It doesn't happen. But if you have found this person, first and foremost, you need to prepare some questions for them. Then you need to record this from suit and then run the test. So here we again need a special stage to prepare test cases. Consequently, after the data has already been run, the data is homogeneous here, no additional transformation is needed. We receive the result, which is relative to every transaction. This project will continue data validation. It's not that we run once a week, once a month, but after every trigger. Similar example is creation of data lakes. Here you can see an old scheme of internal data lake where we connect data from all possible sources like HR, Slack, Google Mail, and so on. What are the differences between the first one and this one? The data is not homogeneous. Consequently, each data source has its own tables, differences, various transformations. Usually, data lake is not limited by data lake. You need to include further telepipelines and form certain data warehouse. So at each stage we can generate tests. We get the following tables. We see here in the graph the backtrend. They can be filtered according by date, by data source. If you know that something has already been run, you'll be able to see it, find in the table this data. Let's say we think that there are too many failing tests, and we talk to the data developers and trying to understand if it's a bug or it's a feature, and something has changed in the process. Thus, if earlier I told you about data ETL pipelines that follow the creation of data lake, because, for example, we need not to pull this data in the raw format in the storage, but also we need to aggregate it, and for this special endpoints are created. Here we can create a bucket in EVS, the storage of transformed data. What is the data transformation at this stage? We drop some columns in data source, we rename them, possibly create our own based on certain metrics. Usually it's called transformed or staged data. We can use it somewhere. What do we do at this stage? We take the data, the raw data from the source, and generate tests. We receive a certain result. Let's say Bamboo HR tells us that data quality is 80%. It's not great, but it's okay. Let's work on. We launch a certain transformation based on this data, and next we take the suit generated in the first stage and we apply it to the data that received after the transformation stage. If the figures don't match, something happened during the transformation stage, and we know exactly where it happened, we can dig into our test reports and see what's wrong. Let's move on. After the data ETL, after the transformation, there's a step called curation. It's in data aggregation. Out of all the tables, we can pull a single line, apply a certain math function, receive a figure, an SLA, and then save this all at the S3 with the bucket. Or we can move it to a warehouse that is called Redshift in the cloud, and then we can draw various graphs for our management. Because it's much cheaper this way. When it's all done, we can draw something like this. There is raw data, transformed data, and between them, we see that there is a difference. We try to understand what's wrong with this. Next case is about the email. ML, a little bit less than we usually do. This is what all the data quality assurance projects started and understand why it's needed. We had a case of a client who wanted to detect using photographs if a child has predisposition to a cataract using the iris. And guys would spend much time to get the 90/95% accuracy of the data since the medical case. Consequently, they tried to change all the hyperparameters, use different models, but they never got the figures they wanted. But they went to their data source that they never assessed, and they saw that the data was not correct. Different background, different zoom, something they cannot track with their algorithm. There was some black pictures. Consequently, after they deleted all that, there was a difficult manual task, but the result was surprisingly nice. They had the 100% accuracy achieved. If we talk about the tools that are available in the market, we made a special table for that. I made a special table for that. I need to mention that we mostly work with table data. The data from data lakes, they could be used not with products but with open source data. Since we're a consulting company, our client doesn't really want to buy the product because somebody recommended it to them. They usually select an open source, and here you need to convince them that we should use this, not that. You can see our main criteria here. The Great Expectation is a tool written using the Python, I think about 3 years ago. And before that, they were a small startup in California. Now they've grown up and collected a number of investments, and they're moving fast soon. There is a DQ or a PyTQ from Amazon. First and foremost, they were looking up at them because this is a native tool for cloud and WES. But for some reason, they give up on it. The last algorithm they had was last year. It was small fixes. They don't have any test reports. They only put something in the console. So this needs to be implemented. The Great Expectation had a plus of having a lot of tests written out of the box, a lot of integration, and other databases. Test reports are quite easy to understand. There was another tool called Patch Griffin in the market, one of the oldest in the market. That's the main problem, that it's quite old, it's not supported regularly. It's easier to have it written in Python.
So the engineering pipelines are written on Python. So if you want to integrate, you'd better not use your own language, but use the same one. Also, we know all that there is such tool as dbt, but it's not its main area of use. It's more are often used to transform the data, and also they added the function when you can test it. And well, why it was not very good for us, because you cannot really retrieve it from the code, only using different Veriflow or other operators. We not always use Veriflow for orchestration. And one of the other perspective tools is Soda SQL, which is the same as Expectation. A startup from US, which raised some investments. Well, they are similar, but the only problem is that SQL is used as a drive to write tests, to build tests, and we better not bring in these extra issues to the project. So that's why we decided to stay with Expectations, because it's written on Python. We can easily use it, share with our data engineers. It has a lot of integrations on various documentation, because it's launched on different drives. You can launch it on Parquet, and or you can orchestrate it with Airflow. You can modernize it easily. You can write your own test cases, your own units, and also there is a reporting system which can also be moderated. And also they start to produce some kind of sub product where you don't have to do anything on your own. It's all set up. You just send them the results of your test runs, and it's huge sum, but we prefer to control everything on our end. Actually, these are the data sources which it is using. So almost everything that there is in big data. Plus, we research different options of how to use it with Spark. Correspondingly, we have contributed some in it. So we wrote how to use it with Glue, with Spark, with the Mars, and they also have a very nice community in Slack. So you can write to them, to that community. Maybe I think they will reply you. So which bugs we can find with the Expectation? So it's all that we discussed in the first slide about dimensioning data quality. So correspondingly, we can find the bugs which are falling on validity, uniqueness, timeliness, and it's all in there. And after writing the code, you can detect all that, catch it, and send it to the developers to fix. So, what are the benefits you get after implementing the data quality in your data engineering pipelines? You save a lot of time on data cleaning, because the data engineers, they normally, when they develop their algorithms or transformations, something doesn't match, fails, so they have to manually find what's in there wrong in the data. So you just give them the hint what to search for, they manually find it quickly, and they kind of normalize all these pipelines, and it's more efficient. Also, there can be some monitoring, like BI Halzak organized, because data testing is not only for about development, but also about production. So because you can transfer all that to different drives and apply to your data. You can set up some specific averting for failed tests, like Slack, and also you can, after each test run, you can send to Slack data source 3 new bugs, take a look. It's much easier for everyone. They just look at it and decide whether to fix it or not. And at the end, it really reduces the costs of all possible transformations and use of tools. Same as in standard testing, the main task of good data quality here is to reduce the cost of error for developers. The later we detect the bug, the more money we spend on it. I will tell you a little more about the way we do it, using which tools basically. Um, so 15 minutes left. Okay, so we use an Amazon Cloud for most of our customers. It's there is a Terraform module developed, which via one click deploys in the customer's account a solution which is a basic solution which works with S3 bucket data lakes applied and generates automatic tests, saves them in the report S3, sends them to Avert as Slack, and also we use a tool which is called Allure. We made a plugin on our own which converts the expectation format to Allure, which is more like clear, looks more transparent, and also they can be referenced to Jira tickets integrated in there, and then all the data are saved in DynamoDB. So, and based on this metadata, so what's in this metadata? How many tests done? What were the test results? And also links to the reports. And we retrieve it to QuickSight, where a person can go, click on the table, look at the report, study it. So this is our basic approach. Also, we have such things as comparison or comparison of data. We prefer not to compare them directly, because if you have gigabytes and they are processed at Spark, so comparing number of strings here or there. So comparing string by string, it takes a lot of time, a lot of efforts. So that's why we also use this expectation tool. We run tests on a certain producer. You remember this raw data where we generate the tests, and then at the end we get some number, and then we run tests like for the consumer target data. So we get some value and compare to these two values. So if there is incompliance between these two values, then there is an error in there. And all the tests are saved, so we can go there and compare. And also there are a lot of open source libraries. We use the DataCompile library, which also has the direct information, but it works natively quite quickly on Spark, so you can show difference between the data schemes, between how many strings are different. Normally, that's what the customer wants to see. That's it for now. I'm ready to answer your questions. Thank you. Are there any questions? Thank you for your presentation. Great Expectation, is it a tool without a thing or the client, or what is it? Yeah, that's your some computer which you use in the pipeline or local if you want to play with it. And it's like a Python library, just a normal one. Hello, thank you for your presentation. My name is Elena. I'm from Arrival Company. So you mentioned that you can use rule-based algorithms, or you can do it manually. So how to choose that, and what does it depend on? So if you really understand that you got three tables, for example, and I'm not going to add anything else. So it's better to do it manually because they will be more thought over, more valuable. But if you get more and more new dynamic data sets, and every time you have to do it anew, you won't be able to write it manually. So then you'd better use these algorithms, which will make a data quality guide for you with uh, so it depends on which rules you apply to that. Great Expectation has been implemented has implemented its own role-based algorithm, but you cannot set it up. It's been set up for you, and you apply your dataset, and it gives you tests. But whether these test cases will be right for you, I don't know. We also use pandas profiling, which allows to make the profiling easier. I mean, collection of statistical data, and based on statistical data, we generate these tests role based. And I have forgotten regarding the QR code, our website on data quality. There are links to different articles. You can read them if you want. Another question. Hello. Do you test housekeeping? So I mean deleting all the information which is out of date or irrelevant. Well, yes, you can monitor that if you write some specific tests manually. It depends on the case, actually. So you can do that. And also, this information can be automatically deleted based on some specific rules. It fits the data quality concept. And my answer is yes, probably. That's it with this one, this question. Я задам вопрос на английском. Вы показали изображение и трансформацию, которую вы сделали с этим изображением, чтобы улучшить код процессинга и так далее. То есть вопрос, какие вы использовали для этого операции и вот проценты, если... Ну вот я посмотрел на изменения, как они менялись. Там, в этом коде, то есть если я сделал какие-то рандомные изменения, например, с 17 до 19%, например, то есть вы как-то контролируете, помимо вот этих изменений, которые вы делаете, чтобы сравнить, какой-то контроль применяется? Но, да, то есть, как я уже говорил, это был первый подход к проекту, чтобы понять, что качество данных важно. И этот процесс, ну, там контроля нету, но там используется какой-то эвристический метод и очистка данных вручную. То есть сейчас мы больше работаем со стороны данных. То есть не со стороны имейлов, а со стороны именно данных. Над этим. Bogdan, tell me, why did you decide to go in data quality? Because it's a new topic, new subject. It's not very widespread, not very popular. Why did you decide to go into that? So this is the attempt to call Halivar. I mean, I was bored working in automated testing only, and there were some transformations in the company towards email data, and that became just more perspective. I started to read some articles in the media, and I decided to look at it, and finally I made something valuable, I think. Are there any questions left? It seems that there are no questions for now. Bogdan, thank you very much for your presentation.